This is our first test of the year. Every single test is going to have the exact same format. So first, on every test, we're going to have 20 multiple choice questions. And they're going to be worth 4 points each, so that's 80% of the test. Now, out of the 20 multiple choice questions, 15 are going to be on the chapter. So what I mean is they're going to be conceptual, they might be short answer problems, but these are going to be directly related to the chapter. A lot of times this is where you'll see like a picture or to see if you understand, again, conceptually the concepts. The last 5 questions are always going to be based on a reading paragraph. Why do we have a reading paragraph on the physics test? Well, the reading paragraph has to do with physics. So on this particular test, it has to do with the scientific method, and then there's going to be 5 multiple choice questions relating to it. So I'll say like, what's the main idea? What does this word mean in paragraph 3? Why are we doing this on a physics test? Because they told us that they want every academic teacher in the district to emphasize reading in your class. So what better way to do it is on the test. Now, once you see these on every test, you're going to think these are the easiest questions because they're actually very, very simple. Okay, so you'll actually look forward to these. You'll like the reading paragraphs. So we have 15 from the chapter and 5 from the reading. And the reading is always going to be related to what we're learning, what we just learned in class. Okay. So that's 80% of the test. Then we have 2 free response questions. Those are worth 10 points each. Now, in these questions, you have to show all your work. So if we're working a problem, you'll get a point to write your given. Then you'll get a point to write what you want to find. Then you'll get a point to write your basic equation. Then you'll get 2 points for substituting in the values, 2 points for solving, a point for your answer. So whenever we have an FRQ, if you just wrote an answer, you're going to get 1 point because the answer is only worth a point. You have to show all your work. So again, when performing a calculation, you need to write the basic equation, rearrange the equation to solve for the unknown in terms of the known, substitute in your values, include units, write your final answer, and then box your final answer. All right. Normally, we're not going to tell you everything exactly you need for the test because whatever we learn, you'll need to know for the test. But since this is the first test in physics, you're not familiar with the format, and we're just going to go over everything we learned, and you'll see, yeah, that's what we learned. That's what we need to know for this test. So first we did the scientific method. So you obviously need to know like the order of the scientific method, like what comes first, second, third, fourth, etc. Then we did measurement and metrics. So we did conversions. And these are the ones you will have to memorize for the first test: pico, nano, micro, milli, centi, kilo, and mega. You need to know relative size. So what do I mean by that? We already did 2 labs. When we did the labs, did you use a meter stick to measure in centimeters? Did you also see on the meter stick millimeters? But we used a meter stick for the blood lab, so we should know that about how big a meter stick is because we held one in our hand, didn't we? So if I ask you how large something is compared, and I'll say, well, this is the measurement closest to a meter, a centimeter, a millimeter, you should know relative size, how large something is. So if I said to you, trying to think an example, I have a highlighter, and is my highlighter, the thickness of this highlighter, is it closer to 2 millimeters, 2 centimeters, 2 meters, or 2 kilometers? So don't you know relative size, how thick that is with a unit? So that's what we mean by relative size. Okay? And it just has to do with the units you've been using so far in class with measurement. Because it's not just memorizing and converting. You should have a fundamental idea of how large something is. Significant digits. So you need to know the rules for addition, subtraction, multiplication, division. You need to know the difference. You have to understand accuracy and precision. We also did scientific notation. 1 integer to the left of the decimal point. You have to add, subtract with exponents using the calculators that we practiced with already. Graphing, you have to know what's the independent and dependent variable. You have to know how to find the slope of the straight line, delta y over delta x, which is y2 minus y1 over x2 minus x1. You need to know what interpolation and extrapolation is. So if there's a graph and they ask you to interpolate between the data points, you need to know how to do that. You need to know the formula for percent error and be able to calculate percent error. And then topics, again, from the laboratory, how to correctly read basic equipment. So how do you properly use a meter stick? You read to the smallest division and you approximate between the lines. How to read a graduated cylinder and how to read a balance, because we did that. You need to know the equation for density with mass divided by volume, and then how to calculate the volume of basic shapes like we did in the lab. All right, so now we're going to go over the review sheet. So when we look at the review sheet, the first question on the review sheet has a graduated cylinder. And that's what we used in our density lab. So it says the graduated cylinder below contains 500 grams of the liquid. So first of all, I have to ask myself, 500 grams, what is that? Well, 500 grams, that's the mass. And then it says, what is the density? Well, density is mass divided by volume. So in order to calculate the density, I need the volume. So now I'm going to have to read the volume from the graduated cylinder. So on your copy, it's kind of small, so it's hard to see. But this is 200 and this is 300, so the volume is going to be 250. So it's 500 grams divided by 250 milliliters. So then my density, I could do that in my head, is going to be 2 grams per milliliter, which would be answer B. Everyone should get an A on this test. If you don't get a good grade on this test, I don't want to say while I'm recording. Okay, number 2. It says the diagram below represents a rectangular object with a mass of 450 grams. What is the density? Well, again, we know that density is equal to mass divided by volume. So the mass, they already told me, is 450 grams, but I don't know the volume, but I can calculate the volume. I know that volume is equal to length times width times height, and again, we did this in our density lab as well. So this is 15 times 5 times 2, and when we do that on our calculator, it comes out to be 150 centimeters cubed. So then I put 150 centimeters cubed here, and 450 divided by 150 is equal to 3 grams per centimeter cubed, which is answer C. Now on your review sheet, I reduced it, but if I look at this, it says which line segment has a length of 3 centimeters. Now, you're not going to have a ruler on the test. So you have to look at that and say which one of them looks like to be about 3 centimeters. So you should have an idea from measuring in the lab. So this one is actually, so there's my centimeter. So that one's about 1. So this is about 3 centimeters, so the choice is B. But again, from measuring, we had 2 labs so far where we measured. So you should be familiar with how big a centimeter is. If you're not sure, go home tonight and use one of your fingers and say, okay, you know, like my little pinky is a little bit wider than a centimeter, so you have a good idea. Because remember, a long time ago when they first measured, they actually used their body to measure. All right, so now we're going to go to the triple beam balance. So it says a piece of copper metal, and this is what you're going to do when you take the test tomorrow. You're going to have an FRQ paper, and the back of your FRQ paper is going to be your scrap. So you put your test and you put your scrap side by side because you don't write on the test and you write on the back of the scrap. It says a piece of copper metal is correctly placed on a triple beam balance. The riders are all at the 0 mark except for the rider on the whatever. So it says, what is it? So this is, do you know how to read an instrument properly? That's why this is on the test. So again, we reach the smallest division and we approximate between the lines. So the smallest division, this is 5 grams. This is 5.5 grams, but it's right on the line. Remember, you approximate between the little lines. So for this, I would write 5.50. Now we're back to the triple beam balance. We did this yesterday when we did our regular. This is reading a graduated cylinder correctly. So it says the diagram below shows 3 graduated cylinders. The contents of X and Y are poured into Z. So I'm going to add these two together, and I want to know what's in here. So I have to read this. So this is 250. This one is 100, and when they add them together, I get 350. So then they have the little choices there, so 350 would be letter C. Again, it's a lot easier to look at this large copy, and on the test there won't be a question. You'll be able to see it. All right, number 6. A centimeter is 0.1 meter. So this is just a simple conversion.
Pardon this interruption. Good morning, teachers and students.
So this is just a conversion. And again, this is a simple conversion, so you can just move the decimal point. And when I want to go from, so you're saying, what is this? And actually, this isn't even a conversion. It's just saying, what's this in exponent form? This is actually easier than I thought. So the answer there is B, because 0.01 is equal to 1 times 10 to the negative 2. All right, number 7, the diameter through the equator of Jupiter is about, and they give you this long number, what's the distance in scientific notation? So this is just, scientific notation. So you just take that number, here's my decimal point, and you go 1, 2, 3, 4, 5, 6, 7, 8, 9. So my answer is 1.43 times 10 to the 9. So my answer is A. Number 8, when measuring the distance between Atlanta and New York, which would be the best unit? So again, a millimeter, that's the little teeny weeny lines on the meter stick. We know a centimeter is about a little bit wider than my small finger. Is that a good unit? A meter, well, that's the meter stick. So obviously the largest unit is going to be the best, which is going to be the kilometer. All right, so now we're going to go to the next page. So the next page says, the graph below shows the population beginning in the year 1800 and projected to the year 2000. So this is basically just understanding graphs. The graph shows the greatest increase in population. So the greatest increase is going to be where we see that really the slope is going to be the steepest. So when we look at this, we see that the place where we see that would be over here, because this is almost like a zero slope, right? And sometimes what I do is I draw little pretend tangent lines. Okay? Here's my little pretend tangent lines. A tangent line is a line that touches the curve at one point and one point only. So I see the greatest increase, because this only goes to 2000, is between it's going to be right here. That's the steepest, right? The greatest change. So it's going to be here, and my answer is B. And then the last multiple choice question is, the graph below shows temperature readings for a day in April. The average rate, so here's the key word. Remember, we want to realize that whenever we read questions, there's always going to be a key word when they ask you what you're looking for. So the average rate of the temperature change in Fahrenheit degrees per hour between 6 a.m. and noon. So I'm going to look at 6 a.m., which is right here. I'm going to go to the graph. That's 6 a.m. So I know at 6 a.m. it's 30 degrees. And then they said noon, so I'm going to go to noon. Here's noon. I'm going to go up to my graph. I'm going to try and read that. It's a little bit less than 50, so I'm going to say maybe like 48, because this is like 40, so it looks like 4/5 of the way up. So at noon, I'm going to say this is 48 degrees. So I see that the change was 18 degrees. That's the difference between 48 minus 30 in 6 hours. So 18 degrees over 6 hours is equal to 3 degrees per hour. And that's my answer. And then on the back of the worksheet, we have practice multiple choice, and you just have, those are very simple, and there's going to be a couple of those on the test, and you go through those, and then that's it.